Okay, hello and welcome back. Today what we're going to be looking at is solving something called quadratic inequalities. Boom. Quadratic inequality example, x squared minus 2x minus 8 greater than 0. Now this should look very familiar because we've just got done recently solving quadratic equations. A quadratic equation very similar to this would look like that. What's the difference? Well, obviously, the equation has an equal sign, the inequality has an inequality sign, a greater than symbol. Now, we've found with linear inequalities that there isn't just one or two solutions. There are infinite solutions. We look at solution sets. Well, solving a quadratic inequality, finding that solution set, is a little bit more complicated than a linear inequality. But the process is very similar to solving an equation, at least initially. If I were to solve this equation, the first thing I'd look to do is to solve it by factoring. And let's see, this would factor into two binomials. First terms would be x, factors of negative 8 that add to negative 2. That'd be minus 4 and positive 2. And this would give me solutions of x equal 4 and x equal negative 2. Now, when we were solving an equation, we called these solutions, we called those the zeros of the equation. We also called it the roots. For solving inequalities, we're going to use these points. But I call those, and this is my own phrase, jumping off points. All right, and why I call them jumping off points, I think will become clear in a little bit. So, solving an inequality, I'm going to factor, just like I did, and find these jumping off points. And I know that they're 4 and negative 2. So I've got those. I've got the factored form of the inequality. Now, I'm going to go ahead and plot these jumping off points on the number line. So at x equal 4, about right there. X equal negative 2, about right there. Now, I want to know, when will this inequality be greater than 0? Another way of saying that is, when will it be positive? Well, I've got something times something greater than 0. This will be true if I can plug in values of x that will make this factor positive and this factor positive. That'll be greater than 0. Or if I could plug in values for x that would make this factor negative and this one negative. So I'm interested in finding out, when will both of these factors be positive? When will they both be negative? Now, the most straightforward way to do this is by examining these factors on the number line. So over here on my number line where I've got my jumping off points, I'm going to put my factors. I'm going to be examining x minus 2, or excuse me, x plus 2, and I'm going to be examining x minus 4. And I just want to see where on the number line are each of these factors positive and negative. For what values of x is x plus 2, is it going to be negative? Where is it going to be positive? Where is it going to be 0? Well, it turns out that where it changes signs from negative to positive, positive to negative, is at its jumping off point. Examining x plus 2, his jumping off point that factor yielded was negative 2. Now, if I look on the number line, and I'm out here in the negatives, like at negative 20, negative 10, negative 15, and I'm plugging those values for x, this factor, negative 20 plus 2, negative 10 plus 2, negative 15 plus 2, it comes out to be negative. So out here, this factor is negative, and then it stays negative all the way up until I get x equal -2. I plug in -2, -2 plus 2 is 0. And then for values of x after -2, plug in -1, 0, 1, 2, 3, etc. It turns positive. And that's why I call these jumping off points. Maybe there's a better term, switching points or something, because the factor jumps off at this point from negative to positive. Okay? And examining x minus 4 the same way. Out here for values of x, big negatives, I plug in for x, I get negative, 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 negative. Plug in -2, -2 minus 4 is -6, still negative. Keep going, keep going. Where does it finally change at his jumping off point? At x equal 4, he's 0, and then it turns positive. Now, I've got a picture on the number line here of where both of these factors, or let me say the signs of both of these factors, where they are positive and negative. Why am I looking at that? Well, I'm interested in examining where are they both positive. Well, by looking at my picture here, where are they both positive? Well, out here to the right of 4. So if I choose any value greater than 4, both of those factors will be positive. This inequality will be true. So one of my solution sets is x greater than 4. Cool? But I'm also interested if both of those factors are negative, because negative times a negative is supposed to be greater than 0. Where are they both negative? Well, out here to the left of -2. So I got two separate solution sets. I've got all the numbers greater than 4, or all numbers less than -2. And I would be, or I would want to write this in interval notation. And so I'd write x greater than 4, that would be from 4, left limit, 4, right limit going to infinity, or means union, x less than -2. That would read from -2, negative infinity is my left-hand limit, because my left-hand bound goes on to negative infinity to -2. So that is my solution set. All right, not too bad, I don't think. Let's take a look at another one. Let's take a look at 3x squared minus 27. But let's make this one less than or equal to 0. And my erasing skills still have not improved. Okay, first step, what are we going to do? Anyone? Come on, raise your hand. Yeah. That's right. What we're going to do is factor and find the jumping off points. Now when I do this, really I'm examining the equation, not the inequality. And the first step in factoring is the greatest common factor. And then I've got a difference of squares here. So that's going to factor like x plus 3, x minus 3. And my jumping off points I'm going to get, that factor is going to yield x equal -3. And that one's going to yield x equal 3. And so just like before, I'm going to put those on my number line. Oh, that's way too far out. 0, I'll call this about -3 right there. And we'll call this one right here 3. a lousy 3. Cut me some slack. When I'm doing this, it's very early in the morning. Still waking up. Okay, so now I'm going to write my factored form of my quadratic here with my inequality. Now actually I've got 3 factors. I've got 3, x plus 3, x minus 3. However, this constant factor, will that affect the sign of the inequality? It's a positive 3. Does multiplying anything by a positive 3 change the sign? No. So to examine when is this expression less than or equal to 0, I'm just going to be looking at when do these factors change signs. When are they positive, when are they negative? So I'm going to be examining x plus 3 and x minus 3. And I want to know when will it be less than or equal to 0. The equal 0 part is easy because I know it will equal 0 at negative 3 and 3. So these points at negative 3 and 3, those are going to be part of my solution set. The little bit more difficult part is figuring out, well, okay, when will it be less than 0? Well, if I'm multiplying 2 factors, to get something less than 0, that means it's going to be negative. For that to be true, they would have to be opposite signs. Like so. So I'm interested in knowing when do they have opposite signs. Again, I'm going to examine these factors on the number line. Looking at x plus 3, when is it positive and negative? Picking out values to the left of negative 3, I'm plugging in negatives, I'm getting negative, negative, negative. At negative 3, it turns to 0. And after negative 3, that factor becomes positive. X minus 3, again, plugging in values out here, and on the negative side, I get negatives until I get to x equal 3. Plug in x equal 3, I get 0. And then it's positive. I just realized I didn't give you a name. What we're making here, this is called a sign chart. Okay, so I'm interested in figuring out when will these 2 factors have opposite signs? Well, to the left of negative 3, they're both negative. To the right of 3, they're both positive. Where do they have the same sign? Right in here. So my solution set, instead of getting 2 separate solution sets, I get all numbers between negative 3 and 3. So I get a double inequality. But we said less than or equal, and I know that this expression will equal 0 at negative 3 and 3. So I make it or equal. And in interval notation, that looks like this. Whew! A lot of work. Now, there are shortcuts. And I'm hoping that you're going to find some of these shortcuts. And we'll explore some of that tomorrow. One thing I want you to consider that will lead to a shortcut is by looking at graphing this quadratic. Graphing y equal 3x squared minus 27. And using our graphing calculator, I sketch that, I get something that looks like this. Now, points I'm interested in are my zeros. And of course, we know that those are 3 and negative 3. I want to know when will this thing be less than or equal to 0? Well, y is equal to that. So I want to know, where are the y-coordinates less than or equal to 0? That's where the y-coordinates are below the x-axis. Well, that's all these points right here. Yeah? Yeah, yeah, those all those points, they have negative y-coordinates, don't they? They sure do. So, by looking at this, I can see that from -3 to 3, that quadratic will be less than or equal to 0. Boom. That's what we found right there, wasn't it? Yes, it was. So we can find the solution set just by looking at the graph. All right. Now, I've got a couple problems I want you to do for tomorrow. And I want you to solve these algebraically with the sign chart like I was doing. But I want you to also see if you can check it, verify it, perhaps with the graph. Or maybe you have another way. Let's see. That one, give you one that's a little bit tougher to factor. So those are the two problems I want you to do. Okay. That'll give you something to chew on, something to work on. I might have you put these on the board, and might be for a board point. It might just be you. So I would do this problem if I were you. Both these problems. So we'll see you tomorrow and see what you come up with. Adios, amigos.